Hey guys, Satyajit Pattnaik here, and welcome back to my channel. Today's use case is going to be on flower classification. It's a multi-class classification problem, and Nilesh Verma, who's a 2020 graduate, he is also working in the field of machine learning, data science, and analytics. So he's going to do a code walkthrough on this particular use case. Let's get started, guys. Before you get started, please like and share the videos and subscribe my channel if you haven't subscribed to get notified on my future videos as well. Just a disclaimer to let you know that I have already started going live on every Sunday 7 p.m. Indian time. So I'm doing a lot of webinars and workshops on various topics. In case you haven't joined the channel yet, please join, and let's get started for today's video, guys.
Thank you, Satyajit, inviting on your channel. And my name is Nilesh, and I have currently working on Nani.ai as an NLP engineer. Today, we are talking about multi-class flower classification. So, what is the basically problem statement today? We have discuss further. So, let's get started. Okay. So, our problem statement is basically we have one two, 02 flowers. We need to classify in a multi. It is basically multi-class problem. So for that we need to build a AI model, and the other end we have built to GUI model. We can deployable GUI model in a way that can, if you any people give the flower, and then that can be predict the flowers name. So this is basically a 102 flower data set. So in this flower there is 1 to 0 categories of a data set, and then in every category is 40 to 25 42 to 58 images are there. Okay. So from in this is the link, basically I have provided the link in our description. So from there you can download the all the data set, all the data set, and then you can just use it for the model training. Okay. So this is the basically data set image. From there you can download the all the data database, all the images on your computer, and then this is the data split file. Okay. So in that file all the train test split or file are there. You can go through, and then you can just make a folder, and then you can put in all this file on your separate things. Okay. So for that, basically I have already done for you. You don't need to do anything. Basically I have created the downloading data file. So from there you just go and just run it in Python on download file, and it is basically automatic downloaded the flower data zip file, and then unzip it. And in this file basically the three things are there, like train file, validation file, and test file. So let's see what is the what is the in that file. Okay. So train file having 102 of the number. This is basically numbers, one to number. All the flowers are put it down the numbers. So if you 6 numbers, so you can give that similar kind of flower out there. Okay. So this is the basically all the flowers, and the particular flower index, there is one file, this is a CSV file. So all the flowers index the number is 6 index. So their name, what is the flower name, and their scientific name, and all the details are in a CSV file. So if you have want to predict the flower name, so you can easily get the through the index name, and then you can easily get the category name and scientific name, all this thing detail on the your system. Okay. So first of all we need to this is the basically all the files we need to download it. If you have I have sharing the GitHub in GitHub the link, so you can also download all the file. So first of all there is one file is PyTorch FastAI model building. So first of all we are using FastAI for the FastAI basically is a PyTorch based if you're using mostly TensorFlow, you know about Keras. Okay. So similar kind of FastAI is a wrapper of PyTorch. So it is basically if you want to rapidly developing any kind of model, so you can use a PyTorch based FastAI. So basically in Jupyter we can going to Jupyter notebook and just opening the our model building model building process. Okay. So first of all
Nilesh, can
in
you
fast
just scroll? Can you just make the font a little bit bigger? Like scroll and
yeah, okay, I can, yeah, okay, I can make the bigger. Yeah, it is now visible.
yeah, visible.
Yeah. Okay. So this is the basically I didn't run it on the our system. Basically I have run it on once, so didn't need to run again. So I just explaining one by one per cell, so you can better understand what are going to internal. Okay. So first of all, we are importing the FastAI. We need to install library. What library need? So there is like a requirement file I have already created. So there is for GUI basically we are using Streamlit. So you need to install Streamlit also, and then FastAI you need to install in Pandas, NumPy, and Google Drive. So for that you don't need to do anything. Just you can run on a pip install requirement. Pip install uh, -r and requirement file. You just and then all the requirement need install on the PC. We don't need to do on all the thing. Okay. So this is the basic download file. First you need to run download dot py file. After that you first you can run install requirement file, and then you run download file. They download the data set, and you have like all the 3 folders, so you can get it. Okay, so let's start it with our coding part. Okay, so first of all we need to import all the fast vision libraries, all the modules on a fast vision model. Okay, and then also we need to import all the metrics model. Basically it is importing the all the metrics and all the vision related modules. Okay, so for some warnings, if we have like using warning, ignoring some warnings, and we need to also if you using there is a two version. First is the GPU version and CPU version. If you want to use GPU version, you need to check where you have installed the 𝐸𝐿A. Basically 𝐸𝐸A is basically used for the GPU processing. If you have laptop having the some GPU GPU processing, so you can utilize this processing for using 𝐸𝐸As. Okay, so you need to install the 𝐸𝐸A library if you want to use GPU. So there is you need to check if your device support 𝐸𝐸A or not. So you can just run this command. So it is print if you type 𝐸𝐸A print. So if you are you have devices having 𝐸𝐸A supported, and you can use the 𝐸𝐸A for the training. And if you didn't have, so they print a CPU, so you can also train to the CPU also. Okay,
Do we have any minimum requirement for installing PyTorch? Like some people might not have that high end configurations. Any
yeah,
requirement?
actually I think there is no actually we can say like minimum requirement. It depend on the task, what task you are doing basically. So if
Okay.
you are doing like image classification task, so I think minimum i5 processor or 16 or like 8 GB of RAM are like, if you depend on basic
It's enough.
data, what kind of
Yeah.
data you want to train. Okay, so similar i5 is like minimum requirement you can say. Or for the like 8 GB of RAM you minimum need for the GPU training, or some 2 GB or 4 GB of GPU if you want to train on GPU.
Okay.
So you need like 4 GB of minimum
Okay.
GPU.
And people who
Okay,
don't have certain system requirements, they can use Google Colab as well, right?
yeah, there is Google Colab also. You can just go to Google Colab and run on there. Okay,
Yeah.
so
Okay.
first up we have just printed the 𝐸𝐸As. Okay, so our devices basically support the 𝐸𝐸A, so this is printed the 𝐸𝐸As. Okay, so after that we can just empty case, just some of the sometimes if you run many time on a 𝐸𝐸As devices, so some of the cases catch are in there. So we just torch 𝐸𝐸A empty case is that you can run it. It is just clean the all the 𝐸𝐸As. Okay, so first up and then second we need, first of all we need to set the path. So like root path where all the your file is located. Okay, so all the files located on my root folder, like one same folder. So I just leave the blank. If you have any file are located on different folder, so you can just folder name you can mention, and then that folder name file are all the loaded on the your working environment. Okay, so I'm just not putting anything because all the things are in a same folder, so it is still automatically detect all the file. Okay, so path that ls basically print the all the file in located on a particular file you have selected. So this is the basically printed on printing all the files like ape.py and all this thing, this is the same directory. So it is basically print all the file located. Okay, so after that basically we need all the thing okay, any models we have using, we need to load all the images. So first I have very easy to load all the images. You don't need to write anything and functions and all those things. You just need to give the training path in our main path, training path, and validation part. Just give the main path. There is like library image data loaders. So in that modules you have to call them from folders. So from there we just give the training folder name and validation folder name. So from there it automatically get all the file. And also if you want to perform some augmentation, so in that classification problem, I didn't provide much more augmentation. Basically, I just resizing the image to 2 to 4. Basically, our model is basically need to 2 to 4 size of pixel size of image for input. That's why we have assigned 2 to 4. I didn't do any much augmentation. But if you want to augmentation, so you can use many of the available augmentation. So I think there is classes like get, transform. So in this class you have first you need to import these classes, and then you can just use any kind of lots of augmentation are there. You have flip the images, flip vertical flip, horizontal flip, max rotation, max zooming, and different kind of you can see all the brightness, contrast, crop, different kind of augmentation are there. So you don't need to do write a code for everything. So you just mention that, and your image is automatically augmented. Okay. So after that you have done, and after that you have done you have just in data, all the data are come up the data object. Okay, all the data in train and validation are you know uh, in a data folder. You have data object, you have get. Okay, after that you need to if you want to see how many classes are how many classes of images you have imported in data, and what is the basically how much classes are there. So in that data and vocab is basically a keyword, and the data.vocab you can use, and then you can get all the classes on the images you have imported on the data. And also if you want to count the classes, the data.c is you can use. It is basically count the 102 classes. So it is written the 102 classes are in that and there. Okay, so we have cross check all this thing. After that, if you want to see a sample of your data images in a classes, so you can just use data dot show batches. Basically it is show the some samples of the images, you can see 73 class. This is the image, 39 on a class, this is of the image. So it is show the sample of the images if you use the show dot batches. Okay, after that we need to check how many data in a train on how many data are validation. So just you can just go use data train ds and data dot valid ds. So from there you can just find the length of the how much the data are basically training time at the training size, data size, and the validation data size. In training, we have using 6,552 images, and for validation we have using 818 images on this approach. Okay, in this classification problem. So after that we have done all this thing, and then we need to load our models. But basically, so for model we have in a vision model there is CNN learner. So if you want to import all the CNN related model, computer vision related model, so you need to use the CNN learner the classes. So from there you need to just put the data. It is automatically detect the training and validation data, and you don't need to mention the training data and all the validation data. You just need to give the data objects. Okay, after that we have loading the model. Basically for the training we have we are using transfer learning. So there are many kind of transfer learning you heard about, RSNet 15 and VGC19, all this thing. So basically we have using VGC19 is basically very dense 19 layer network for image classification. So you can see there is 19 layer. So there is a stacked convolutional neural network. So if you image for the images classification, the convolutional neural network are mostly used. Okay, so it is basically very dense neural network which is 19. We don't explain everything about VGC19. We can make the separate video for this, but currently I'm just a basic. I have go through the basics. I know. So there is a 19th layer. So it is collection of 19th different kind of layers. So yeah, we can see two are convolutional layer and one is max pooling layer, and two stacked again two convolutional layer, max pooling layer, and four convolutional layer and max pooling layer, like this. And last there are three connected layer, and then last is softmax function. Because if we are using multi-class classification, so softmax is basically used for the multi-class classification problems. Okay, so this is the basically architecture. You can see this is the more if you want to see how kind of things are the gear. So you can see all this thing, and all, yeah. Okay, So we are going the like after that we have like mentioned the matrices also. For the matrix, what kind of matrix you need to optimize for the model. So basically we have using accuracy and precision, recall, and FA score. It basically what kind of a matrix you want to print in a training time. So you can mention in matrix matrix parameters. So like we have a mentioning accuracy, precision, recall, and FA score. We are using averaging macro because macro averaging basically if you have like multi-class classification, so we need to like, use average like average all the prediction, every kind of predictions of every model, every like multiple classes. Okay, so we can like a weighted average we can calculate, and then it is basically used for that. Like precision and recall and FA score we have printed on the model train time. Okay, so after that we have like mentioned default devices because we have the CUDAs. So if you didn't have the CUDAs, you can just define the your default devices on a CPU also. But I have the CUDA devices, so I have mentioned the default devices. So it is used, forcefully use the CUDAs for the training time. Okay, so for that, like after that we have like mentioned the learning. So you just need to like learn. We have like mentioned this is the model learn. Okay, just learn and fine tunes. So in 5 approach, basically we have using in a like training period. So there is like 1 2 3 and 4 5 and 5 training time are running one by one. So you can see like all the approach training loss and validation loss, and every approach accuracy you can see, and precision, recall, and F1 score in a form of tables. You can also see the
Yeah.
what is the training time on the
Okay.
yeah. Hello.
Yes. Correct.
Yeah, okay. So you can see all this thing. Okay, so we can see like 98% accuracy we are getting on this training model in which is in 19. So it is very good, give good accuracy score. And the image classification is 98%. We can say like surely identify what kind of flower is it is. So it is good accuracy. So after that, if we have like saved all this thing, so we need to like export the model. So we have there is like export features like learn.export module. So after that you can just run it, and that is your default path. If you mention in this path, so it is in that path, it automatically like store the export.file, pickle file. In pickle file they store the model and automatically
Okay.
store the model on a pickle file. Okay, so we have done the training and exported the model. Okay, after that we need to like write a prediction function. So simply we have like simple thing we have generally write a prediction function for that. So for that I have like written and simple loaded the image, simple image I have loaded. And then for every classification model need to run on a learn on a error like a matrix format. So we need to convert in matrix. So NP array we have like use the converting the image, all the image to the array format, and then we can give the input to the prediction model, so that it can be predict more predict the classes, what classes they are. So basically if you run this is basically run in that prediction. So it is basically I didn't run it all this thing, because basically if you run it, so it give the output of the prediction, all this thing prediction.
Yeah.
Okay, so kind of like probability, the if you want to, there's like a, if you I have created the prediction function. So it is basically predict if you give the like that image. So it is like creating the image and open the image and correct like converting on a np numpy arrays, and then give the probability and the predicted classes. So okay, in the particular classes if you predict the classes, and then you can go to the your like csv file, and this is the csv file. So you can get the which data are basically and there, and you can find all the detail of the flower. Okay, so it is the basically model we have building. After that, this is the model is creation done, and then we have go through the GUI part. Basically for the GUI building, this is the basically app.py file. So for the GUI building we have using uh, Streamlit. Streamlit is basically very famous, tools for the creating the GUI very rapidly. You don't need to learn all
Again, can you,
CSS or HTML.
Nilesh, sorry, sorry
Yeah,
to
hello.
interrupt. Can you just make the font little bit bigger in your pie chart? Oh, sorry,
Yeah,
your
okay,
Visual
okay.
Studio. Yeah.
Yeah, okay. Mm. I think control plus.
I think you can yeah, I think control plus I think works.
No, no, actually they're not running. Where to
Control
actually?
control scroll. Can you try control scroll?
No, no, not working control score.
Okay.
Actually, I didn't. Where is like view? I think there is appearance.
I think it's okay. You can continue. Yeah, should be in appearance.
Central layout. Zoom. Yo, control plus equals to okay, okay. Control plus same ही है. Okay, yeah, it is zoom
Yeah, it
now.
works. Yeah,
Yeah, okay.
yeah.
So basically, uh, this is the file. Okay, okay. So it is app.py file. So basically in there we have like all the GUI based things are there. So from there we have like in this all the file we have need to run it, and then we have the see the all the GUI. Okay, so first of all I am just running the GUI, and you can see the how the like for the running an streamlet you need to run right stream lit run, and then you need to mention app.py. So app.py you have mentioned and just click the run. So it is basically run on your local system. Yeah, yeah, you can see running, and you can see how the were like model are basically running. Actually I think this is also zoom, so actually I said, yeah, this is our model. So basically in they have like flower prediction apps we have like mention all this thing. And then if you there is two options like if you have used from the test images, so we have in a sample images we have like put it some sample images for you, like in anybody you can see like all the images and choose any images. So this is basically a sample test data, so you can also test on sample data. So it is predict all the things, like the flower names you have, they mention the flower name and the probability, what is the probability of that flower, flower names, and of all the details of the flower like scientific names, location, which location they are found, families,
Hmm.
species, and bloom type. So it is like print all the things. Okay. And if you want to like use it like want to predict in our flower, your own flower, so also you can use like your own images. So you can also upload your own images, like any images you can upload, and then for uploaded image they are also predict.
Okay.
Let's see, it's I think running. Yeah, it is also predict for that images. Okay, what is the probability and all this thing. So let's get
Hmm.
started to coding part. So what is the code in an internal? So we can see like there is like yeah, simply you can just import all the library. Streamlit is basically you can need to import, is basically main library we have using for the GUI building. And that pillow we need to import for the images, pandas for the CSV loading, and all the OS file and FastAI vision, like we have trained in the vision, so we need to some import for loading the models vision library. So we need to like import all the model like vision based models also. Okay. So first of all we need to like set the path. Okay. So there is like not, I'm not using like like multiple things on that. This model is like all the in a saving on a root directory. So I just mention all the model only, because I don't need to like access all those things uh,
Yeah.
in a like things. So in model, so I just mention the export.pkl, and then that this is load the model. So there is like load learner we have imported load learner. So basically load learner is basically load the your like exported file in a for prediction. Okay. So you can load this file for, you can use this learn function for the prediction. Okay. So
Okay.
for flower.csv we have like importing pd.recsv. Simple, we can just access all this csv file, and then we can set the index column is index, so we can access easily. So I have written two functions for get name. So get name function is basically in python, is it basically simple python code. So I just go for the index, and like like category name is basically in a number form, 1 2 3 4 5, like
Yeah.
102 numbers. Okay. We just like you can give like give the one category number, and then just it compare the numbers, and then return the name of the basically flower name. Like so we can like in there
Yeah.
we have used this function, we can use in the flower name. Okay. And then there is like a
So basically,
get
your
details.
output is in numbers. Your output is in numbers.
Yeah,
You are just
yeah,
mapping
yeah.
the numbers with your CSV file and giving the scientific names. Yeah.
Yeah. Basically, all the files, I say earlier, all the training file are in a number, 1, 2, 3, 4, 5. Like, there's no
Yeah,
associate name. So they need to like,
yeah,
match the
correct.
index to the numbers. So in this get detail also. So get detail function is basically return the detail of the image. Like we have currently we are there all the detail of the flower. Okay. So get detail function is basically return all the flowers name, flowers details. Okay.
Mm-hmm.
After that we have write the predict function. So simply we have like, give the images name, and then np like, just already converted the images, and then predict the, you can just see that this is the predict image function. So it is basically predict the flower, predict the numbers. So you even get the numbers. So from there you can just put down the get name. So it is basically return the name, and then you get detail. So we can just give all the get the all the
Yeah,
detail of the flowers. Okay. So it is basically return the three things basically predict function return. One is like name. Second is basically like how much percentage, like probability, what is the probability basically of the particular image is like in lie on a particular category. So basically
yeah.
this is the probability number. They return this. So three things we need to mention on the things. So this return three things on a functions. Okay. After that we have like using this is the basically for the for good looking application. You need to some like you need to some, you can also in a Streamlit there is like if you want to use some decoration type of things. So you can easily mention through the HTML temp. So HTML file you can also like use any HTML file for like designing your application. So in there actually I am simple HTML file I am using basically. So like flower prediction is the title, and then this is the description, or description is basically simple HTML code. And then we are just
Mm-hmm.
ht.markdown function is basically no render this HTML file, and you can see this is the basically render file. So this is basically R. Okay. So after that we need to like two radio button. We have to give like a multiple choice. So we can say like if you choose this one, and this value are return, and if you choose this one, this value are return. Okay. So for that like we have like options. We have, there is like a radio button. st.radio is basically a module. So from there we have like use that mention the two in a list form. You can mention the choices of what is your choices. So you can easily mention on your choices on st.radio file. So from there you can, if you like if you want to three to any one like you need to create the list. So you can, from there you can also like create the multiple radio buttons. Okay.
Mm-hmm.
So this is basically option. So if you choose any button, so this is basically written on the return, and we have saved the but particular value to the options. So we can check after that we can check option. We can check it, like if the option is choose image for on image. So we can like if your image is like a simple sub, if you have choose one image, so we need to like write for this type this for write this function. Okay. So we need to like write for the uploading files, and then all this thing. Okay. So for that we have like st.file uploader. One is the function. So from the st.file uploader we need we have like you can just define it is basically upload the file. You can also define the type if you want to like user only upload the jpg file. So you can just in type function you can just define type of your like any of the extension, what extension you want to upload.
Mm-hmm.
Okay. And this is the basically name, like if you want to give the your file uploader name, so you can just choose a image file uploader name you have, I have given. Okay. So after that this is basically file uploader. It is uploaded file. After uploading the file, this is the save on the uploaded file. So we again checking if the file is uploaded. Like the file is sometimes the file is not uploaded, so it is not execute. If the file is uploaded, that is execute. After that we know like uploaded file having the images. So in we have using pillows. Pillows is basically load the images on the particular
Yeah.
uploaded file. After that we have like just give the predicted image, and that image in internally they have like convert the arrays and give the predicted learn.predict file, and then after that we have written three files like in predicted class and probability and details.
Mm-hmm.
Okay. So all the probability we have got three files. So we need to just like we can put on a way that will look like very good, like good looking way we can put on the our
Yeah.
GUI models. So for that I am like using columns. Like there is a column function on ST library, Streamlit library. So you can like just mention two columns. So basically, if you want to three columns, you can just mention three. I have mentioned only two columns. So column one and column two, there is the return the two columns. So with like we can use with function in column one. So it is basically load column one data, and with column two, they are loaded two like column two data. Okay. So like see, you can see
Okay.
like we have like two columns. Like column one is basically images, and column two, this is the
Yeah.
basically column two. So there is st.image, but just we have uploaded the image and just view the that particular uploaded image, for the user preference, what image you are uploaded, and that is predicts. And after that, we have like printing the, if success, like printing the flower name and probability. So basically there is
Mhm.
like lots of printing functions on Streamlit library. So success info, like very warning, if you want to print warning. So there are multiple type of printing function that print the files. So I'm using success. Success is basically it print the anything on a, in a green color, in success
Okay.
success like module. Okay, so str
Okay.
success is basically I just mentioned flower name, and then the predicted class, and then we just print the predicted class, and then info is basically clear the, like in a, I think, a blue color, and then we have simply probability part we have printed. Okay. And then just in table, basically there's st.table table module. In table we have
Mhm.
like also in any data frame we want to print on the output, we can just print on the table module. So this is the table,
Mhm.
like we have print the all the data frame output on the table format. So it is basically return the tables. Okay. So similar kind of thing we have also done in this manner, but we have like mentioned this is the sample images. So I just loaded the OS library for the list directory in sample
Okay.
images. So this is basically list all the images on the particular folder. After that, we have used like select box, like multiple choice selected, and we have used, and this is basically return the list. So in the multiple choice, we have like load, this is the, so, and
I
if
see.
you like see this, so it is basically in the form of list. Okay. So if you
Okay.
select any one of the folder on the list, like they return the name of the folder, name of the file. Okay, particular file. So in test image, we have like the name of the file are you know there. Okay. Plus after that, in file path, we have just merge the two file, like sample images and the test
Mhm.
images. We have like merge it to the we can get the main file. Okay, we can get after main file. So in file images, we have like get the total full path of the images. Okay.
I mean, I can see that this code is pretty easier as compared to Flask, right, Nilesh? Because मैं Flask में काम किया हूँ and Flask has a lot of HTML and CSS concepts as well. So I think Streamlight is going to be easier for the people to implement any end-to-end projects. So I'll definitely recommend people to get started with it. And really, thanks for joining me and showcasing your project. It's an end-to-end project. I was expecting it to finish it in 10-15 minutes, but it's almost 30 minutes. So really thankful. And for all of you, Nilesh will be sharing the code very soon, which will have everything in details. The comments will be there properly so that you can go through and you can understand it in a better way. And definitely, it's a very good project for college beginners and for who are getting started with machine learning. I think it's going to definitely boost you up, and we'll come up with such sessions as well, Nilesh. And thank you for joining again with me, and thanks for watching this video. If you like, please like, share, and subscribe the video. Thank you, guys.